We begin by pressing Create Tests in our plugin menu, which creates a module script that holds our test data. Inside this, we have a parameter generator function and a functions table. The parameter generator function is used to create input data to pass to our functions as parameters. This way, if you are benchmarking functions that need vector 3s or parts to operate on, you can pass that in via this function. It is called outside of the timer, so a slow generator will not affect your results. This sample starts by having it generate a random number, and as you can see, our samples are set up to accept that as a parameter. The first parameter will always be our profiler tool, which we'll cover in detail later. We can change sample A and sample B to more descriptive names so that when we view the results, we can tell what function it's actually referring to. For a quick demonstration, let's test two ways of creating an array. We'll fill these arrays with the random numbers that are passed as input. When we run this, we're presented with a line graph, a bar graph, and a statistics window on the side. The stats window results are ordered, so the top is the fastest function. The stats displayed are the 10th percentile, 50th percentile, 90th percentile, minimum, maximum, average, and total timings that were gathered by our benchmark. The line graph is a histogram, which is an approximation of the distribution in our gathered data. The x-axis displays the time in milliseconds that it took to run, and the y-axis displays how many times the function ran in roughly that amount of time. Hovering over a point on a line tells you which function that's representing and the value at that point. The vertical line marks the 50th percentile of the function's distribution. By looking at the histogram, we can see that pre-allocating the array size with table.create is not only faster, but also more consistent as it has a much tighter distribution. Our bar graph is handy for visualizing the difference in speed relative to each other. We can clearly intuit that pre-allocating the array size takes roughly 80% of the time. It is also a hybrid flame chart for detailed profiling of your functions, but we'll cover that in a little bit. On the function names in the stats window, we can toggle the visibility of each function in order to isolate and declutter. Hiding a function will re-render our graphs and charts so that they are zoomed and calculated as if the hidden function does not exist. This is extremely useful when testing many functions at once so that you can compare them one at a time, in groups, or all at once. We have a drop-down panel of settings in our menu with some handy features. Up first we have run amount, which sets how many times the plugin will run your function, essentially setting how many data points to collect. 500 is a great setting, but it's there if you want to change for specific cases. Next is graph points. This setting changes how many dots the graph uses to display. This doesn't affect your actual dataset, but rather how precisely it is being visualized. I like to keep this around 125. The next setting, baseline 0, sets whether the left of the graph is at 0 milliseconds or at the minimum recorded value. When at the minimum recorded value, the graph is basically zoomed in to the relevant parts so that you can clearly see any distinct differences, whereas when the graph is at baseline 0, it's more zoomed out and gives you a sense of scale so that you can understand whether those differences are significant. Finally, we have graph outliers. When gathering data points, sometimes there will be one or two random calls that take like 50 times longer than normal. We do count them in our dataset, but when graphing the visuals, it's usually more helpful to ignore them because if we zoomed out to see the outliers, our relevant data will be too shrunken to easily analyze. Therefore, we don't graph them by default, but the setting is there should you ever need to view the entirety of your dataset. Alright, let's talk about the profiler. This tool allows you to break down your function and see which parts are taking the most time. Instead of only knowing the time the function took as a whole, you can find out which operations are the slowest parts of this function. It's given to your functions in the first parameter, as we mentioned earlier. By calling profile.begin with a unique name, you open up a profiler chunk that will measure the time it took to reach the next profiler.end call. You can nest these calls and break down your functions even further if you want to get even more details. When your functions are using the profiler, the bar graph on bottom will double as a flame chart and display the profiler breakdown using the bars as the root label. This is very handy as it allows you to have your relative speed comparisons even on the smaller profiler chunks. Hovering over a chunk will give you a complete stats rundown for that specific chunk. By profiling these functions, we learn that table.create takes much longer to initialize the table, but then it's much faster at populating the array as it doesn't have to keep allocating more space every time you insert a new value. Some of you may wonder why you should use this plugin over popular alternatives like the Roblox Micro Profiler or Valdocs Benchmark module. Before I get into the advantages of this plugin, I will say that it's often best to use multiple tools to double check accuracy. Those other tools are great too, shout out to those creators. That said, this plugin does offer a variety of advantages. The most obvious one is the histogram. Being able to visualize the distribution is incredibly informative, and those others simply do not give you that information visually or numerically. Another key advantage is that this plugin uses the 50th percentile for its calculations and results, whereas others, as of recording this, only use the average value. Average values are a generally unhelpful metric because one or two statistical outliers will completely skew the average value and will no longer be representative of the function's real behavior. This plugin provides you with percentiles, mins, maxes, averages, and totals so that you get a wide range of metrics for the most comprehensive results possible. Another advantage is that this plugin allows you to run your functions in an isolated environment with controlled input parameters. It doesn't require you to run your whole game just to test one function, and you can control exactly what the function is operating on. This plugin is just a great all-in-one package. It does everything you need: profiling, histograms, bar graphs, and detailed stats. It basically covers everything that the alternatives do combined into a single plugin. Well, whatever your use case might be, I hope you enjoy this plugin and find it useful.